Now we're going to look at a couple more examples of graphing exponential functions. So again, we can pick any x values. I'm going to do -1, 0, and 1. And we're going to evaluate the equation based on those x values. So when I substitute that in, we have 3 times 2 to the -1. Remembering PEMDAS, we have to worry about the exponent before we can multiply. So 2 to the -1 is 1/2, which means we have 3 times 1/2. Not 1/3, 1/2. And 3 times 1/2, 3 over 2 is 1.5. Substituting 0, 2 to the 0 is 1, 1 times 3 is 3. Substituting 1, 2 to the 1 is 2, times 3 is 6. So we've got the point -1, 1.5, 0, 3, and 1, 6. To find our horizontal asymptote, we would just say y is equal to whatever number we're adding or subtracting at the end. Here there is no number there, which means it's 0. So this graph is going to approach 0, it's going to get really close to it, but again, never actually touch it. So here's our graph. Again, these are just rough sketches, as long as you don't cross that horizontal asymptote. Our domain, -infinity to infinity. Our range, we're getting really close to 0 and then going up forever. So we have parentheses, 0 to infinity. In the next one, we have y equals 1/2 times 2 to the x minus 1. This x minus 1 in our exponent, that's going to make us shift to the right by 1 unit. Picking some x values, I'm going to go with 0, 1, and 2. Notice I shifted up 1 each time because I was paying attention to what that exponent is. So when I substitute 0, I have 0 minus 1, which is -1. 2 to the -1 is 1/2. So I have 1/2 times 1/2, which is 1 over 4. Substituting in 1, 2 to the 1 minus 1, 2 to the 0 is 1, times 1/2 is just 1/2. And then substituting in 2, 2 minus 1 is 1, 2 to the 1 is 2, 1/2 times 2 is 1. So we're going 0 up a tiny little bit, 1 up a tiny little bit more, 2 up exactly 1. So this one's getting super flat, and that's because of this 1/2 at the front. Since this 1/2 is a fraction less than 1, our graph is going to flatten. If this number in front is bigger than 1, our graph would stretch really tall. Sort of like what happened in the last example. We had that 3, so it got tall even quicker. This 1/2 is going to make it take a little bit longer to get really tall. We're not adding or subtracting anything at the end, so our horizontal asymptote is at y equals 0. We have to make sure we graph that asymptote. You cannot forget to graph it. Then starting off really close to the asymptote and going through those points. That's a rough sketch of this graph. Domain, all real numbers. Range, 0 to infinity.